All right. Good morning. Good morning, everyone. Just a second. Let me open the chat window. Please confirm if I'm audible, loud and clear. Guys, can you put a message in the chat? I can see some hand raises. I also want to see some messages in the chat. Can you even put a message in the chat? Are you able to put the message in the chat? Can anyone put yes or no? We want to see a message in the chat. I'm not able to see any message. Can you put a message in the chat, guys? Okay. You're not able to put the message? That's weird. Can anyone please reply in the chat? Am I audible? Chat is open for all. Okay. Can you see my message in the chat? I have said a message. Can you reply to the message? Okay, just a second. Let me check. Guys, chat option is enabled for all. Why you're not able to put the message? Attendance. Okay. Can you check now? It's enabled. All right. Thanks. Thanks. Thanks for the confirmation. Okay. Now it's available. Fine, fine. Now we can interact. Perfect. Just one more minute. Yes, good morning. Good morning, everyone. Fine. Very good morning, guys. Let me start the recording, then we can continue with our session. Perfect. Perfect. So in last session, we have discussed about deep learning, right? We did one project on ANN, and that was handwritten digital cognition project. We also discussed about activation functions. What are the activation functions there? Uh, what we have it for the regression techniques, and what we have for loss functions. So all the things we have discussed. Today we are going to take one step forward, and we are going to start with a new topic that is going to be CNN. So let me share the screen, and we can start with the topic. All right. So what I'll do, I will be sharing two files with you. This particular file that is about CNN, This is just having the simple content like to get to know you about CNN, what CNN is, and this is going to be our project that you're going to do today. So today we'll be working on a project called cat and dog classification. So we will be using real, like original images of cat and dog, and we'll be training the model on that. And we are also going to check when we are passing a new image what the model is going to predict, it's cat or dog. So this type of things we are going to do today. First of all, our discussion will start from CNN. For the time being, I'm sharing this file with you, so you can keep this file. Just a second. There is nothing to run in this particular file. CNN is just about the content. All right, so I have shared this notebook. Fine. So you can take this notebook. I'm sharing the link again. Just take this notebook. What you can do, the best thing, you can click on file and you can save a copy in that, right? So one copy will get created and you can save it with any name. Fine. Now here we'll be starting with CNN, that is convolutional neural network. Now if you remember, we have discussed about neural networks. In neural networks, three basic or three major categories that we have used was ANN, CNN, and RNN. So our discussion is going to be on CNN today. So now CNN, as we know, like it can be used for multiple purposes, but the major purpose that if you're going to see is going to be image classification. So one of the main category to do image classification and image recognition in neural network, we use CNN, convolutional neural network, like face recognition, object detection, scene labeling. For all these particular areas, CNN are getting widely used. Now, one reason behind using CNN is, so here we can easily work on multiple color channels. Color channel means what? If you are going to see one image, let's say this image is a colorful image. Not yesterday, the last session that we have used the image, it was of grayscale, right? Grayscale we have used. Share the file again. Sure, I'll share the file again. Here you go. I have shared the file again. No problem. Yes. Now, here what we try to do, we try to work on multiple channels. So channels means what? In the last project that we have done, we were having grayscale image. Grayscale means what? You can say black and white. Okay, any two colors. So the shade of gray is higher or lower. Based on that, you will getting the value, that pixel value. Here we will be having three color channels. That time we were having only one color channel. What are the three color channels? We have red, green, blue, RGB. Now it is going to work on those color channels, and from there it will try to extract the information. Now here if you are going to see, we have one image, and this image that you can see, three sheets are there. Why there are three sheets? These three sheets represent three color channels. Three color channels. So RGB. From all the color channels, we will be extracting the important part of the images. That is going to be a convolutional layer. So we are going to create convol features. What is convol feature? How it is calculated? We'll see. After a convol features, convolutional layer, we will be adding a pooling layer. Pooling layer, what it will do? Pooling layer will try to extract only those pixels that are having higher value in a given in a given window. So window size will be giving, and you can have multiple convolutional layer, and one convolutional layer will get followed with one pooling layer. And with convolutional layer, we used to add one ReLU activation function. So I hope activation functions are clear. In the last session, we have discussed about activation functions, right? So I hope all these things are clear to you. So you can have a number of convolutional layer followed by pooling layer, and after that what you will be having, you will be having flattened layer, and after that fully connected. Now this particular thing we have already discussed. This part is nothing but ANN. I told you, whatever the neural network that you're going to build, base is going to be A. So here we got the sort of NN over here, and once the convolution is done, that means you are able to extract the only important features, the pixels values from the picture. You are going to flatten it, and afterwards you will be creating the fully connected layer over there. Here you will be adding multiple layers of your choice, and then you will be having that output layer, right? Fine. Moving ahead, here what we will be having, we will be having some sort of calculations. We'll see like all these calculations. So what we used to do when you are going to see convolutional network. So in convolved feature, you are when you're going to add one particular layer of convolutional layer, so you will be adding filter, multiple things. Filter means what? Here we are applying a filter of a particular size, and from there we are going to get one convolved feature. So let's say this is the original size of your image, and you are multiplying it with a filter. So this filter is going to create convolved features. So actually you are having a higher dimension image, you are going to take it in lower dimension, and it will get created as a convolved feature. So convolution of an image with different filter can perform different operation. Like you can blur the image, you can sharpen the image, you can detect the image, right, and all these things. Then we will be having the concept of stride, padding, and all these things. Let me take you directly to the file first of all. Okay. We are going to learn all the things while doing this particular project. Okay, so we'll go slow, and if you want me to repeat anything, you can just let me know. And for the time being, to make the process a bit faster, here I have selected a GPU. How you're going to select the GPU? So from here you can see change runtime option is there. You can click on change runtime. Here T for GPU. You can go with CPU also, but CPU is going to be a bit slower as compared to GPU, right? Now, the first thing that we are going to do in the last session, guys, I hope you remember image data generator that we have seen in regularization technique, right? Regularization technique. So here we have TensorFlow. From TensorFlow, we are using importing Keras to add the layers and all. And from Tensor, we are also importing TensorFlow for different work as well, direct. And from Keras, we have some sort of modules where we have image. And from here in this module, we are going to import image data generated. So first of all, I'm going to run this particular line of code. And afterwards, we will be importing the data. Data means what? Image data. So these two lines basically tell you about image data generator. Let me take you to my folder, and what these images are going to be about. I will show you the images first, and I will share the drive link also, drive link for the images. Okay, it's taking some time. Might be my network is slow today. Let me reload it again. Yes. So in my drive, So here I am having a folder. I will be sharing this folder link with you. This folder have two folders, train and test. And in each folder, what you have, two more folders, one folder for dogs images, one folder for cats images. Now let's see the dogs images first. What type of images we have? So I'm just going to show you this images. So dog, here you can see we have multiple images of dogs, and these are the real images, not generated and all. So real images we have. Fine. What about cats? Let's go to the cats folder. So here we go. We have cats images. Right. So images of all the different shapes and size we can see. Yes, some humans are also included, but mostly it's about cat. Fine. I hope you got to know about the data set. So data set is nothing but folders of images. Okay. You have folders of images. So you have train set and you have test set. In train you have folders of cat and dog. In test also I'm going to show you. In test also we have two folders, and these folders have the image in sorted way. We have for dogs. Okay. All right. And we have one folder for cat. Okay. Fine. So we have cat folder also. Now we'll try to use this data, the data set that we have, to train our model. Okay. What I am going to do, guys, I'm going to share this folder link with you. Okay. I'm going to share this folder link with you. And what you can do, you can download this folder or you can save a copy in the drive. Both option you will get. Better you save a copy in the drive. If you are going to download, it will take time. And let's suppose if you want to download and you want to keep it with you, uh, simply you can keep it keep it somewhere in zip file only. Let it be in the zip file. Whenever you want, you can unzip that. So as you know, when you're going to download a folder from the drive, it will get downloaded in the zip format. You can unzip it and you can use it. You can use all the things locally also. So here is the dataset link, cat and dog dataset. Yes, I will be sharing it. Drive link I have shared. I'm going to share now this particular collab link. Yes, I'm sharing this collab link also. Cat and dog classification or image classification project. Done, shared. All of you have got right. So both you can just whatever the thing I'm sharing with you, it's on collab only. Better to create a copy on your drive. Fine. So let's get started over here. Few things were already discussed. Like if you remember in the last session, we have discussed about regression technique. One of the regression technique was image data generator, data augmentation, basically data augmentation. the image data that we are importing, at the time of importing it will get processed, it will get augmented. So that's what we want. So here, after importing all these modules, we'll come over here. Here we are going to create train data generator. Let me do one thing. Let me clear all the outputs so that outputs also you can see. Fine. So here what we are doing, we are using image data generator module, and with the help of this particular module we are creating one object, train data gen, that is train data generator. So for training set we will be using this data generator. What is techniques we are using? Rescale 1 by 225 255. Now here what we used to do, we used to rescale the image, by dividing it by 255, so that all the values, the pixel values that we are having, will get normalized between 0 to 1. CR range, what exactly the CR range is all about? So you can see all the documentation about the things, like whatever I'm using in this file, you will get to know about all these things. Just a second. Yes. Yes. I'm just fixing the chat window. What rescale is going to do? Rescale is going to divide each pixel value by 255. It normalizes the value to be in the range 0 to 1. Okay, so this is very common preprocessing step in deep learning to ensure the numerical stability. Now if you are having like 200, 210, 150, these are the large number when it comes to train large volume of images. That time your training cost, computation cost, training time and computation cost will be much higher. Then we have CR range. So here CR transformation tilt the image along the axis. So along the axis it will get tilted. So we have tilted it for 0.2. It is set to 0.2 as of now, but that means it is going to shear the angle to 0.2 radian. 0.2 radian. Then we have zoom range. Zoom range basically randomly it is going to zoom in or zoom out the image by 20% randomly. It is going to do randomly. And horizontal flip, it is going to flip the image horizontally. Okay, horizontally it will get flipped, right? So if it is true, and randomly it will get done. So using this we are creating train data generator, right? And before moving ahead, as I can see my file is in the drive. So what I'll do, first of all, my drive need to be mounted. For me it is already mounted. For you, if it is not mounted, please mount it first of all, so that you will get a drive folder. Okay, now we have the data in folders, the images that we have in folders, and another term that we use for folders are nothing but directory. Okay, we call it directory. Now when you're going to create the object of image data generator, let's say I have created train data generator, it has one function, one method called flow from directory. Flow from directory. Flow from directory means what? Taking it from the folder. What we have given? We have given the path of the folder. I have not given the path of the image. I have given the path of the folder. Which folder? Train folder. In train folder, we have two folders. One folder for cat and one folder for dog. Right? So both folder will get taken. Target size. Target size, I am taking 64 by 64. If you want to increase, if you can increase, if you want to decrease, you can decrease. What does 264 by 64 means? Now if you are going to look into any images, just a second. So here you can see all the images are of different sizes, right? What we have to do, we have to fix all the images to one size. We have to take all the images in one size only. We can't give multiple size images to the models. So you will get some error over there. what we are going to do, the target size that we are taking, it will be taken as 64 by 64. No matter what, how large the image you are having, it will be taken at 64 by 64. Now, as of now, we are doing a small scale project, but when you go to large scale project, you can increase the size of the image. Okay, the target size you can increase, but the target size increasing means what? You are also increasing the number of features. So 64 into 64, like 64 ka square, that many number of uh, input features you will be having. Batch size, we are keeping 32. Now, whenever you are going to run the epochs, in epochs, model is trained into batches. So in one batch, randomly, it will take 32 images. Randomly, it will take 32 images from cat and dog. Then we have class mode binary. So why binary? Let me run this. Why we are telling it binary? Because we have two classes, either cat or dog. Binary. So we are into binary classification problem. What we have in total for training, we have 557 images belonging to two different classes. Then we have test data gen. So for test purpose, we are going to do the same. We are taking rescaling, shear range, zoom range, horizontal flip. If you want to increase the parameters, you can increase. What are the parameters you can increase? Let me just show you in the same file. The file name was regularization, right? Guys, this file is already shared with you. Okay, till then let me take one question. One question is there by Prasant. When I paste link in the end of the Power BI course module for completion tag, but error come that username. Okay. So have you given the right username from the MS Learn portal, Prasant? Okay, we'll check it in next half. Okay, in next half one more trainer will join. So I will ask him to uh, clear this type of queries. Okay, you can ask this query in the second half. But remind us, okay? Fine. So in the regularization file, we have data augmentation. So here in data augmentation, what you can see, we have added few more things like rotation range, vertical flip. Now this thing also you can add. As of now, I'm not adding. I'm keeping few things for you. Try to add few more things and see the results. All right. Now we are going to create train set or the training set using train data gen, test data gen that we have created. It's same. You can also use the same train data gen object over here. Okay, that can be used. But for better understanding, we have created two different data generator, one for train and one for test. So train data gen or test data gen, this object of image data generator have one method flow from directory. We have given the directory path. So test folder you have to take, and here you have to take train folder for training set. The same target size, batch size, and class mode. And when you're going to run this, what you will get? You have 140 images belonging to two classes. That is again binary. Fine. Now from here, our discussion for CNN will start. Is it clear till here, guys, about image data generator? What we have done? We have done nothing. We have just imported the images and we have created the set, training set and test set. Is it clear till here? Can I get some thumbs ups? Okay, just give me a minute. Till then, you can put your question in the chat. Just a second. All right. What are the other types of class mode we can use? You can try over here. Let's suppose I'm changing this. So you can see the things over here. What exactly you have. Um, Let me open. So multi-class you can use binaries there, and you can write any other thing also. Okay, fine. So here we will be start discussing about CNN. So CNN is going to be nothing but, first of all, we are going to create the structure of the model. Okay, we will be creating the structure of the model. The structure of the model means what? If you are going to look into this file, and if you are going to go here, okay, so this type of structure we are going to create. So we will be having the image. After that we have what? Convolutional layer, pooling layer, again convolutional layer, pooling layer, right? Then we are having fully connected layer. And uh, so this part will also explain you a lot of things. You have the input image, you are adding n number of convolutional layer, and each convolutional layer will get followed by one pooling layer. Once your convolutional and pooling is done, you will be flattening the layer. So we will try to create this type of structure, guys, first of all. So once this type of structure is created like this, so first of all, what we are doing with the help of feature extraction, so we are doing the feature extraction in multiple hidden layers. On these images. So all of them are going to learn from these images. Okay. And we only have, not only we don't only have koala image, we have multiple images also. Let's say 10 elements images here we have. And what everyone is doing, everyone is learning on all the features, like ear, nose, hand, legs, everything. Now at the end, what they have to do, they have to report to one supervisor. Now one supervisor, one name I'm taking in the chat, let's say Smith. Smith is saying Shrek. Very good. Okay, Kus, for Kus is Jerry. It doesn't have tail, Kus. Okay, now what we have Jeet, we have Sahil, we have Dhruv, we have Chirag, and we have Parth. These guys are learning from these images and they are reporting to one manager, let's say. we have one manager, Smith. Now they are going to give they will learn from this image and they will give their prediction. What is the prediction? Let's say for a time being, Jeet is saying this is a beer. Now you can see there is a lot of confusion in the chat. People are saying Jerry, mouse, bhalu, kuch bhi. Sahil, let's say Sahil is saying it's koala. Dhruv will say it's panda. Chirag is saying, let's say Pikachu. Not animal, but I'm including. Let's say Parth is saying what it is. Jerry. Okay. I'm taking a random thing from here. Now, here the Smith is getting confused. What you people are saying? Someone is saying bear, someone is saying koala, panda, Pikachu, Jerry. Now he is getting confused. What you people are saying? Now don't learn in this way. All of you guys don't focus on the entire, entire part of the image. You can take some parts. You can divide your parts. Now, instead of training instead of training on the entire images, what these guys are going to do, they are going to divide their task. What type of task they are going to divide? Let's say Jeet is going to work on the ears of this particular image, the ears part. Let me just take ears. Jeet will work on ears. Now here Jeet will be able to identify the animal with the help of ear because he is going to be expert in identifying the ears of the animal. Let's say the task of eyes we have given to Sahil. Now Sahil is going to become expert in identifying the eyes of the animal. Nose and mouth, this part we can give to Dhruv. Dhruv is going to become expert for identifying nose and mouth. Then we have, let's say, hands and legs. So hands, we can give the hands to one guy. Let's say Chirag. Hands. And we will be giving the leg part to Parth. The legs. Now we have divided the work. So each particular team member, they are focusing on a particular feature of that particular image. A particular feature, single feature, either ears, eyes, mouth, hands, or legs. Now here, when we have distributed this task, when we have done this thing in a specific way, we are going to remove this type of confusion over here. Now this time what will happen? Everyone will say the image that we are having is nothing but koala. Jeet will say koala. Dhruv will say koala. Chirag will say koala. Parth will say it's koala. Right? Now this time Smith is able to return the output. What it is? Koala. So this is why we are going to use CNN. So convolve feature. We are working on convolve feature. What is convolve feature? Let's try to understand. Let's try to understand. So what we will be having, first of all, let's try to understand this thing first. I'm closing the chat window, guys, for a minute and I'll open it after some time. You can put the message in the chat. So what basically we have the image. The images that you're going to have, these images are going to be in different color channels. Different color channels. All right. So let's say The first one is for red, second one red, green, blue, right? The last one is for blue. Let me change one color over here to green. RGB, three color channels we have. So what you have seen, it was 64 into 64 into 3. This is what? 64 into 64 3 times. So let's say the image that you are having, it is 64 by 64 and it is getting repeated 3 times. So that is 3 color channels. From here, what we are going to do, we are going to add convolutional layer. So we will be adding convolutional layer. Let's say conv 2D. So this conv 2D over here, what it will do, it will try to extract the important features from here and it will put it in itself. So you will be having again one image matrix over here. Okay, you will be having the image matrix. From this image matrix, you are going to have pooling layer. Now, pooling layer again, it is going to extract. Let me create a pooling layer over here. Pooling layer is going to extract again the important features from here. It will take it in it. Okay. Once it is done, if you are done with conv 2D and pulling, so conv 2D and pulling can be repeated. Once it is done, you are going to flatten this. Flattening means what? This particular pulling will get taken as a single array. Okay. And afterwards, what you will be doing, you will be creating the layers of neurons and it will get interconnected like this, like we have discussed earlier. And finally, you will be getting some output. Okay. It depends on how many output features you want, output neurons in the output you want. So this is the basic thing. So from here, input image, we are getting conv 2D, then pooling, and after that it can get flattened. So this is flattening layer. Let me add it over here. Flattening layer. Flattening layer. And this is nothing but the full connection. Full connection, just like NN we had. How the things are going on behind the scene, let's try to understand. Okay, the calculation part. I'm not going to write the calculations and all over here, but I hope you will understand. Let's say we have this image. We have this image. In this image, what we will be having? So after augmentation, you will be having this particular image of size 64 by 64. Now, for the first thing, guys, that you have, over here, let me take you here. You have filter 32. Just a second. You have filter 32. Okay. Kernel size 3. So here we are going to multiply it with a matrix of 3 by 3. Filter 32 kernel 3. What does it mean? Let's try to understand. Now you have 64 by 64 image pixel. Okay, pixel images. And what you have over here, like this, right? Let me take it as blue color. Okay, I'm just taking it as blue color. This 3 by 3 filter you have, 3 cross 3 filter, kernel of kernel size 3. 32 filter means what? 32 times, 32 times or 32 times we will be getting it done like this. So here, this 3 cross 3 from here that you are having, it will get multiplied with this, and one final convolved feature that you're going to get, convolved feature that you are going to get, it is going to store those values over here. Okay, it is going to store those values over here. Okay, so first time 30 3 into 3, this thing got multiplied. Let's say suppose you are having some values over here, random values will be there. Okay, something you have, it get multiplied, some sort of values you are having over here, just giving some random values over here, it is getting multiplied, and whatever the product is there, you are going to put this product over here. Let's say you got 40. What will happen here? We are going to follow the stride 1. Okay, stride 1. So if it is completed this part, if it has completed this part, it will go to next slide like this, next 3 by 3 window. Again the calculation will get made, that is into this particular kernel. You will get some result over here, let's say 51. And what will happen, it will get done on and on until and unless you are filling all these particular gaps over here. So finally what you have, you got a convolved features, convolved feature. Now what will happen, so this will happen in conv 2D layer using filter, using kernel, using filter and using kernel. Yes, it will be random, it will be random. We are not going to put the value, it will be random. Or like you can also edit the kernel also, like for blurring you will be having different kernel values, right? Sometimes we have a specific also, but here as of now we are taking all the random values. So in conv 2D what we have got, guys, we have got convolved feature, and here two things are there that will again come in uh, polling layer. Stride we have taken one. Stride means what? After completing this part, it will shift to next one. After completing this part, it will shift to next one. This is how 32 filters will get applied. Okay, 32 filters will get applied and will fill this particular features over here. The next thing that we will be doing over here, we are going to do pulling with max pull layer. Okay, max pull layer. Let me run this particular thing from here. I'm going to add this layer. Let me first check it is added or not added. If you're going to run this 2 times, guys, 2 times it will get added. Okay, so you have to take care of this. I run this and this layer got added. How much time it's taking? Okay, I think I need to run it from scratch. It's connecting. Okay, just a second, I need to run the things from the beginning. It was idle for a lot of time. That's why got disappeared. Name error. Perfect. So this thing got added. Now what we will be having? We will be having pooling layer. We will be having pooling layer. In pooling layer, what we are doing? Max pool 2D, pool size 2, stride 2. Now what is going to happen over here? Max pool 2D. So the name is max pool 2D. Now the work of max pool 2D will start from here. This convert feature. Okay, this convert feature. I'm going to draw it again. Let's say you have this convert features over here. I will share it, Tejal. Just give me a second. When I will go back, I will share it. Okay. We have two particular parameters. First of all, pool size. Let me just change the color. We have pool size. We have given 2, and stride we have given 2. What is going to happen? Here we are going to extract, from here we are going to extract some important features. Important features means what? Just a second, let me make it parallelly. All right, let's say the values that we are having, it's 40, 24, 41, 59. Pool size 2, stride 2. I'm going to take few more things over here. All right, pool size 2, that means pool size, this is the pool size. From this pool size, which is the pool size 2, that is 2 by 2, 2 by 2 matrix over here, which is the highest value, 59. 59 will get stored over here. Stride 2, move to next 2, that means this particular, which is the highest value, 72. 72 will be taken. Again stride 2, taking the pool size 2, which is the highest value over here in this pool size, 60. 60 will be taken. This is how you are going to retrieve or extract the important features that is required over here. You will be getting the pooling layer. In pooling layer, you are going to do this thing. Once the pooling layer is done, this thing can be repeated again and again. So let's suppose you are having image. Okay, image. After that, you can have conv 2D plus max pool 2D. It can be repeated again, conv 2D plus max pool 2D, plus we will be here adding the flatten layer. Flatten layer means what? Whatever you have got here, this particular array, it should get flatten. It should get flatten. Okay, it should get flattened. And in conv 2D, you will be using ReLU. You will be using ReLU. you will be adding the flattening layer. That means this particular the image array that you have got, it got changed to a one-dimensional array, and after that you can add the neurons over here. You can add the neurons, and you can add a number of layers over here, like the hidden layers, and you will be having output layer, right? Like this. So it will be interconnected. And in this case, the problem that we are solving right now, in this case, we will be having only one neuron in the output layer. One neuron in the output layer. And this neuron, if you're having single neuron in the output layer, or you are going with a binary classification problem, you can add sigmoid over, sigmoid over here. Let me add flatten, then full connection, then output layer. So in output layer, you will be adding sigmoid when you have binary classification problem. When you have multi-class classification problem, that time you can simply go with um, softmax activation function. All right. So I hope this concept of CNN is clear to all. Can I get a quick thumbs up? I'm sharing the collab link. Do you also need this link, that is drive link, image data link, Tejal? Only collab is fine. I'm sharing both. Just a second. Let me share both. Yes. Guys, I think you are leaving the session in between. That's why you're losing the link. So I'm sharing the collab link. This is the collab link. All right. And data set. So this folder link I will be sharing with you again. I'm sharing the dataset link also. All right, shared guys. Dataset link is also shared. Collab link is also shared. All right. Let's come back to our file. Now, what we are going to do, we will be adding a pooling layer over here. All right, pooling layer got added. Then we are going to add one more layer. This is the second layer. The first layer we have added over here. First layer consisting of one conv 2D and one pooling layer we are adding, maxpool 2D. In second layer, we are adding one. So as I told you, conv 2D will get followed by maxpool 2D. The same thing over here, the same filter size, kernel size, and you can have a number of conv 2D and maxpool 2D. Once everything is done, you will be adding the flatten layer. After flatten layer, you will be having the full connection. In full connection, I'm just keeping only one layer as of now to make it simple. So whatever the flatten layer is going to give you, here you will be adding one layer of 128 neurons. Units 120, that is 128 neurons. Activation function ReLU. Now, whenever you're going to add full connection, the function that you will be using dense. So here we are using conv 2D, maxpool 2D, all of the things. Here we are creating full connection. Full connection, you're using dense. In output layer, we are using unit 1, activation function sigmoid. Now, what exactly sigmoid will do? We know sigmoid returns a value between 0 to 1. But when you are using sigmoid in the output layer and you are having only one neuron in the output layer, what it will do, if the value that sigmoid is returning, if it is greater than or equal to 0.5, it will be taken as 1. If it is less than 0.5, it will be taken as 0. That means it could be taken as cat or dog. Here, what is cat, what is dog, we'll see. So here we will add one more dense layer, one dense layer for output, and then you can see the summary. Okay, what are the layers you have added? You can see over here, model sequential. Now let's come to the training part of the model. Here optimizer we are using Adam. Loss function we have changed, that is binary cross entropy. uh, we have discussed about loss function in the last session. So we were having sparse categorical cross entropy. A sparse categorical cross entropy you will be using when you have multi-class classification problem. Last time we were having 10 classes, 0 to 9. So handwritten digit project was a multi-class classification project. Here we are into binary classification project. So loss function here we have binary cross entropy. Metric is going to be accuracy. Let's run this. So compilation is done. Now is the time to train the model. Okay, now training is going to take some time, guys. You have to be patient about training. So cnn.fit, we are giving train set. Now here we don't have concept of x and y. We are giving the folder to the model and the image folder directly, the train set that model has created, the sorry image data generator has created the training set. And here we don't have classes. Classes are getting considered based on the folders you have. So in one folder, like we have the data separated in different folders, right? Data separated in different folders. So for training we are giving x is nothing but a training set. Then we are giving the validation test set, that is test set. The model will get trained and will also validate itself with a test data. And epochs I'm taking 25 as of now. 25 epochs. Let's run this, and now it will take at least 10 minutes. Okay, 10 minutes of time. Here we have to wait and watch why it is going to take 10 minutes. For the first epoch it may take 2 to 3 minutes or even more. And the epoch, the training time depends on multiple factors. The multiple factors are, first of all, what is your batch size? Second thing, what type of configuration your system is having, like the computation power, the configuration of your system. These are the factors. Okay, so okay, here you want me to go? Yes. All right, you also have the file. You can see the output on your own end also. Here the training is started. I have taken 25 epochs and initially accuracy is very low. And for the first epoch, it will take maximum time. Maximum time for the first epoch. And in second epoch, the time taken will be less. In third epoch, it will become more or less, lesser and lesser it will go. The most of the time will be taken is going to be in the first epoch. So here I am using my like using GPU over here. So it will get done in less time. If I'm going to do the same thing in the local system, for each epoch it will take, for the first few epoch, it will take more than 5 minutes. Here it is getting completed in less time. How many of you are running the code? How many of you are trying with me? Any sort of problem you're getting? All right, so first epoch is about to complete. Running. All right, good. In first epoch, the accuracy that we have got, it's around 50%. That is not good. Not good accuracy. We will try to make some improvement in this file, guys. Let's it get completed and we'll try to add few more things. Okay, we'll try to add more layers. Okay, and we'll check it's how it's working. First epoch is done, but it's wrapping up the thing. It will take some time to get it done, and then second epoch will start. So here you go. So you can see accuracy is going up, going down, and two things you are getting: accuracy loss and validation accuracy and validation loss. What is accuracy and validation accuracy? Accuracy that you can see, it is based on the training data. On training data. Validation accuracy, it is on test data. Why we take 25 epochs? We can take 50 also, Jeet. Just for the time being, I have taken 25. We'll try to implement a few more things over here. Okay. So afterwards, what we can see, the training speed is faster. 24th epoch we have raised. Done. So at the end of 25th epoch, what we have observed, accuracy that we have got it 87%. That is good accuracy, not bad. But validation accuracy is only 70%. So this time we can say our model is overfitting. Overfitting problem means what? When model is performing well on training data and it's not giving the the required result or up to the mark result on the a better accuracy on the or batch normalization. Okay, so we have got one trend model, guys, right? This model is trend, CNN is trend now. What we are going to do, we'll try to use one image and we'll try to predict what image it is. Okay, so from kraj.utils, we are having one function called load image. We are loading the image in the same size, 64 by 60. If you're going to see this image look like this. Okay, now if you want, you can also increase the size. Let's say I'm taking 300 by 300. This is the image. But why we can't use 300? Because the model that we have trained, we have given the input image, input size 64 by 64. That's why we are taking the target size 64 by 64. So it will get taken like this. Fine. Now it is in the form of image. As of now, we are going to convert it into an array, image to array. We will get the image array. Now image array, it need to get expanded with the dimension. Axis 1 0 means if you're using numpy, axis 0 means column. Column wise, we are going to expand the dimension. So expanded dimension is going to be look like this. The thing is that the model that we have trained over creating the conv 2D filter size and all. So this particular dimension the model has got. Now we'll ask the model to predict the test image, this particular array. The result that you are getting is 1. Now I have tested this multiple times. So for cat it was giving 1 and for dog it was giving 0. So here if the result is 0 0 1, that is, you can see it is a nested list over here, nested array you can say. So if the value in the array is 1, then the prediction is cat, else prediction is dog. So as of now we are getting the prediction as cat. For dog also it's giving 1, so that's because some sort of error you are getting, right? You can try with other images also. Now the thing is that over here few more things need to get added over here, guys. Image that you are giving to the model, it's also need to get divided by 255, right? So you can pass it through that data gen, the data gen that you have. You can simply have that image in that way, and that image you can try to pass. Okay. Now let's try to add a few more things over here. What are the other things that we can add? We will take few things from this regularization PPT. Sorry, regularization file. So I'm going to, what I'm going to do, I'm going to create a copy of this file. Okay, I'm not going to make any change over here. I'm creating a copy of this file. I'll do the changes over there. Now copy is created. Okay, let's run this. Okay, it is saying too many sessions. Okay, you can't use GPU multiple times. Okay, so I'm just going to terminate that particular session, terminate other session. Now it got terminated. All right. Now the things will work over here. So here what we have. So I'm going to change the image data generator, guys. From here, whatever I have from here, I'll try to use it over there. Done. Targets I'm keeping the same. If you want to increase, you can increase or decrease. Let me see. Is my drive connected? No.
Meeting disconnected.
ना तो कॉलेज में साफ कर रहा हूँ सब साफ किया है 2 बार साफ किया कॉलेज में लव कॉलेज उसका लव सारा आपको विश्वास नहीं है नहीं दिख रहा है ये साइड में नहीं गंदा नहीं है वो आप कॉलेज में
ಅದು ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗರಿ ಬಿಡಿ
गंदा दिखना चाहिए कहाँ गंदा
એટલે પેલા કનેક્ટ થઈ ગયું ડિસ્કનેક્ટ
ये थोड़ा सा निकाल के लगा देता हूँ गंदा दिख गया गंदा नहीं है वो का है
क्या हुआ कैसे हो
ये है ना इसका निकाल
કરિએ છીએ
આપણે પરિચય કરી
स्लाइड ही नहीं ले रहा है
आता निकली
स्लाइड ही नहीं ले रहा है मतलब इंडिया से नहीं लेगा लेकिन कंप्यूटर से अंदर आएगा ना सिस्टम से तो लेगा हाँ लेगा हाँ जोर से ठीक है स्लाइड नहीं लिया अभी स्कैन मारिए कंप्यूटर पे निकालो उसके बाद
જાણીએ તો છું આવું છે
बॉक्स है ये सर्कल છે એનિમેશન છે આની ખબર બનાવો કે
સિમ્પલ છે વીરે
એ વાત છે
એક બોક્સ છે તેમાં સર્કલ ડ્રો કરવાનું છે બોક્સને ફરવાનું ને સાઈડના બોક્સને ઇન્વિઝિબલ કરી નાખવાનું
अच्छी बात 6 महीने नाम
वो वाला क्या कर रहा
આવું આવે સાઈડમાં